All right, here we go. So here's another example where we have two nonlinear equations with two unknowns, and we're going to solve this by using substitution. Okay, so now, this is already solved for y, so we're going to go ahead and plug it in for here. So let's do that. So if we plug that in, we get x minus 5 quantity squared plus quantity 3 times the square root of x minus 8 quantity squared is equal to 25. Okay, so again, we're going to FOIL this out. Remember, this is x minus 5 times x minus 5. This is going to be plus what? 3 square root 8 minus x minus 8 times 3 times the square root. Well, actually, even before we do that, I'm getting ahead of myself here because we have a square root in there. We're going to distribute the exponent to both of these. So this would be 3 squared times the square root of x minus 8 quantity squared equals 25. So I almost made a mistake there, going a little too fast. Okay? So now I'm going to distribute this out, right? So x times x, so that gives me x squared, and I'm going to get negative 5x and another negative 5x, so that's going to be minus 5x minus 5x, and then I get a plus 25. Now this is going to give me plus what? A 9 times what? This is squared, so it undoes the square root, and I get x minus 8 is equal to 25. Now right away we can simplify things. I've got a 25 here and a 25 here, so those are going to end up canceling. I got an x squared, this is going to give me a minus 10x, and this is going to give me a plus what? 9x minus what? 9 times 8 is 72, and that's going to be equal to 0. And now I'm going to simplify further. So this is going to be what? Minus 10x plus a 9x is going to give me minus x. So this is going to be x squared minus x minus 72 is equal to 0. All right. Now the thing is we need two values, which is easy, right? We need two factors of 72 that will give me, well, two values that are opposite signs, because this is negative, that when I subtract them are going to give me a negative 1, so so they're consecutive integers. So they're going to be consecutive integers, and so when I subtract them, it's going to be negative 1. So the obvious two are going to be 8 and 9, okay, which is what we had up here. So 8 and 9. So this is going to factor into what? The 9 is going to be negative, right? So it's going to be x minus 9 times x plus 8 is equal to 0. And so that's going to give me the two solutions that either what? X is equal to 9, or x is equal to negative 8. Now, this is where we're going to pause for a moment, because unlike the other one, we have something that we have to be careful about, because remember the domain of a function, right? We didn't have an issue in the last problem, but here we might have an issue, because remember, we can't have any negative values under the radical here. Okay? So, what you want to do is test these 2 points to see if there's a problem. So if I put in 9 here, I get 1. That's totally fine. Remember, I can have non-negative, so non-negative values are good. If I put negative 8 in here, I get negative 8 minus 8, which is negative 16. That is a problem. I can't do that. So guess what? This cannot be part of the solution. So now all we have to do is test 9, because 9 will work. So when we put in 9, what do we get? We get 9 minus 8, which is 1. The square root of 1 is 1. 1 times 3 is 3, so y equals 3. So the only solution is going to be what? 9 comma 3. And that's it. So the moral of the story is remember to always check your domains, make sure that there's no restricted values, because again, you don't want to get the wrong answer because you didn't check.